Hello, my name is Richard, and I'll be introducing our team's Capstone project called Wyrm, an offline AI hacking and reconnaissance tool developed by Natasha Menon, a computer science undergrad student here at Marymount, myself, Richard Flores, a cybersecurity student, and Matt Penn, also a cybersecurity student.
Alright, to introduce our product, our goal was to create a tool that was easy to use, easy to carry, and versatile enough to adapt to different penetration testing scenarios. We're using custom install scripts, and it's all built on a Raspberry Pi. And what really sets this product apart from any that are currently in the field is the integration of an offline LLM for AI assistance, along with Bluetooth connectivity for stealth and convenience. The big problem we identified is that most existing tools are way too heavily dependent on online resources, whether that's online repositories or APIs. They need frequent updates. This makes them much less useful in environments that are air-gapped or have very strict security controls. So we needed to create a stealthy tool that supports offline capabilities. So this is important because it supports testing for insider threats, which is one of the main concerns in any environment, no matter what. It is very important in critical infrastructure. This will also enhance readiness in secure environments as we're doing penetration tests in those secure environments so we can patch any vulnerabilities that are found. And additionally, this demonstrates the contributor skills in cyber coding, hardware integration, and project management.
The problem that we identified was that penetration testers, red team operators, and other cyber professionals often rely on tools needing or being designed around having internet access for operations and functionality. While these existing solutions are effective, they're not optimized for offline and on-site penetration testing, especially in air-gapped or highly controlled environments where internet access may be limited or restricted. The objectives, this project aimed to address the gap by exploring potential solutions for and developing a prototype tool that would allow on-site cybersecurity offensive testers to implement reconnaissance, weaponization, and delivery with limited internet access. And the significance is that this project will help test the security of facilities against insider threats by providing a small computing tool that could be used by penetration testers to simulate operations and assess security.
Before we began any development and implementation, we conducted a literature review where we first looked into cyber reconnaissance. We discussed the phases of cyber attack, fully defined what deliverables would be needed to perform cyber reconnaissance, and we closely mapped this in our research out to the MITRE ATT&CK framework. Next, we focused on Raspberry Pi pen testing, which is where we explored how these devices are currently being used as affordable and portable platforms for penetration testing. We also reviewed in depth the limitations that Raspberry Pis also have that come along with it. Finally, we examined AI reconnaissance, which is where we investigated how AI is currently being used to leverage and automate and enhance reconnaissance activities. We looked into recent achievements, the integration of machine learning for data analysis, and the implications for both attackers and defenders.
For our methodology, we chose to use Scrum as our framework, where we used a piece of software called Notion to track and plan our sprints, as well as different Scrum meetings. As you can see, we had our active sprints in certain sections, as well as archived tasks that could have been completed or canceled. And we're also able to set the priority, due date, and assign tasks to different team members. Additionally, with our Scrum board, we chose to use Notion for our original project proposal, where we outlined our timeline for each task or each milestone. As you can see, it started from February and goes until the end of this project, May 2nd, where we have our deliverables listed.
Getting into the development and implementation of our product, it first began with the Raspberry Pi setup. We assembled our Raspberry Pi, connected all of its cables, Ethernet, configured the operating system to make sure everything was functional. Once that was functional, we moved on to AI implementation, which is where we created a script that fully utilizes offline large language models, which use retrieval augmented generation with ChromaDB to assist in command generation, and we also installed this script as a Linux tool, so you can call it from anywhere using the command Wyrm AI.
One of the main ways we turned a Raspberry Pi into a reconnaissance hacking tool is by installing the correct red team tools onto it. We use the cyber kill train criteria to organize our different tools. These 4 criteria were reconnaissance, cracking, weaponization, and delivery. And these tools included things like Nmap, John the Ripper, Searchsploit, Veil, etc. Where we were able to solidify all of the commands on an Ubuntu VM, because that's what we were using on the Raspberry Pi. And we were able to conglomerate all of those install scripts for the tools, as well as the dependencies for the Wyrm AI and Bluetooth terminal capabilities.
And finally, we developed a method to gain terminal access to our Raspberry Pi device via a Bluetooth serial connection, binding a terminal emulator to one end on the client side and Getty on the target side for authentication, and automated this using a script. The script also creates a service that runs at boot time on the Raspberry Pi, so every time the Raspberry Pi is booted, it automatically creates this login service so that a keyboard and screen do not have to be connected to the Raspberry Pi in order to gain access to it over the Bluetooth connection. And then we tested everything by compiling all of the different scripts we've mentioned together, uploaded them to GitHub, and then downloaded them to a fresh installed Ubuntu server on the Raspberry Pi, as well as virtual machines, to ensure everything ran properly and sequencing was correct to get the Pi up and running by just running the scripts in sequence. So as a final product overview, our solution is a portable AI hacking and reconnaissance tool with Bluetooth terminal connection capabilities, and as mentioned, that AI command assistant with RAG analysis of installed tools, man pages, and those tools being recon, weaponization, and delivery tools that were selected for their excellent offline use without internet access. It is easy to set up, carry, and use, needing only a keyboard and monitor for initial setup, and then after that, just power, either from a power supply or even a power bank that can provide the required 5 amps of power through USB-C. It can be utilized in an air-gapped environment. It can use either Ethernet or Wi-Fi to connect to the target network, and then connects to the operator over that Bluetooth connection to another device, be it a computer, a tablet, a phone running Linux. And it is easily adaptable to other use cases, adding additional functionality, including additional tools that an operator might want to use, custom scripts. The M.2 hat we use, there is a dual M.2 version that could include cellular connection to provide even more capabilities for offsite control using a cellular signal instead of the local Bluetooth close-in range connection.
Alright, to wrap everything up, we concluded with a working prototype of our portable AI-assisted hacking and reconnaissance tool. Throughout this entire process, we learned many things. One of which was that working with large language models on single-board computers, such as Raspberry Pis, severely limit the model selection and usage. This is because LLMs are computationally costly, and Raspberry Pis just simply don't have the compute power needed to run the latest and biggest models. Additionally, installing tools on different Linux distributions such as Ubuntu, Kali, proved challenging, as all tools have different installation processes, and we ran many tools and had installed many tools. Also, when creating our ISO file, we ran into problems with creating an ISO file that was bootable, which means that it would be able to run on our Raspberry Pi with no problems. And finally, it was challenging to overcome the Bluetooth compatibility issues, managing the Bluetooth stack, and ensuring proper security measures for data transmission. We have also looked into continuing this project, and our future work would be taking our base Ubuntu server, which is what we've been using, and create our unique ISO after running our large scripts. We just need to make sure everything is bootable once we do this. We want to further refine our retrieval augmented generation database querying for more accurate command assistance. And finally, our Bluetooth scripts could be modified to be a remote access Trojan, such as a RAT, which enables local backdoor access after running our scripts. This means we would be able to essentially connect to the device whenever we'd like over a Bluetooth serial connection and have a backdoor into any computer that runs our scripts.
For our lessons learned, some of our key takeaways were that attack surfaces can very much include Bluetooth devices, which was seen in our Bluetooth serial terminal script. And a lot of tools actually have wireless Bluetooth capabilities, which is what we use to be able to SSH into the terminal on the portable device and can allow us to access things remotely. Also, portable tools could help companies test their security, as you can take them into buildings and test security with them right then and there. Some of our future insights is that it's very, very possible to make red teaming and pen testing more efficient. The prototype of our tool is an example of that, as well as physical and digital security being extremely important. The nature of this tool is to bring it in a pocket or a coat jacket into a building to be able to test with it without anyone knowing you have a tool like that with you. And developments require heavy organization to be successful. This was seen in our Scrum methodology and Notion board. Also, don't drop your computer while you're working on Capstone and have it blue screened, just from experience. Thank you.
We would like to acknowledge and thank several people who were critical in the success of our Capstone project, including Dr. Vargas, the professor for this class, who guided us through the Capstone process, Dr. Sankari, our faculty advisor, who started from the beginning reviewing our initial proposal, as well as the work throughout, giving us great suggestions, having us think critically about why we were doing stuff, and providing avenues we hadn't considered. Amy Colvin, Jared Franz, and Paul Davis, who we all interviewed. Amy is a graduate student and fellow Cyber Clinic lead, who gave us some great insights. Jared Franz, Red Team technical mentor and senior security engineer at Millennium Corporation, and Paul Davis, a manager of security engineering at ECS, who I briefly talked to regarding this project and gave some great insight and advice, especially when it came to Bluetooth and overcoming some of the initial troubles we were having implementing terminal access through Bluetooth protocol. Thank you for letting us share our Capstone project with you. If you have any questions, comments, feedback, or anything else, please reach out and connect. We'd love to discuss our work further.